Hello everyone, this is Mr. Underkoffler, and today we're looking at the guided notes called Analyzing Graphs of Proportional Relationships. In previous guided notes, we discovered a pattern with graphs of proportional relationships, and what we discovered I have here in this box. Proportional relationships graphs will always create a straight line and will always pass through the origin, which is 0, 0. For example, take a look at this graph. As you can see, we have the time in hours, the distance in miles, and what do you see? This is definitely a straight line. And even though I only put the dots at these three locations, we can clearly see that it is also going through 0, 0, which is what we call the origin. This is a proportional relationship. How do I know? Because this is a straight line that goes through 0, 0. You're like, well, Mr. Underkoffler, I need more proof. Okay. Let's take a look at the ordered pairs. We have 1, 4, we have 2, 8, we have 3, 12. Let's prove it's proportional by using the methods that we had done with the table problems from the other packet of guided notes. Let's take 4 divided by 1, 8 divided by 2, 12 divided by 3, and if I get a constant ratio, then it is proportional. Well, look, I do get a constant ratio. This is proving this is proportional. And I can go even further with this. We know that the distance was in miles, the time was in hours, so that means my numerators, and forgive me for not even writing this down, but the numerators were miles, the denominators were hours, so this is really 4 miles per hour. And as we learned from the other packet of guided notes, per hour means times the hours equals the miles. So I'm setting up an equation. Why am I doing this? I want to prove to you that 0, 0 works. If I put 0 in for h, what do I get? 4 times 0 is 0, proving 0, 0 works. So, bottom line, I can tell you right now, any graph that is a straight line, if it also goes through 0, 0 and a straight line, it will be proportional. You will not need to do all this extra work to prove it. But let's look at some counter examples. I don't know if I've ever used that word with you guys before. Counter examples means the opposite of what the examples are trying to show. So here I'm going to show you graphs that are non-proportional. Now you might be surprised with this first one. You're like, well, Mr. Underkoffler, it's a straight line. Yeah, but it doesn't go through 0, 0, does it? And here's the work that I was showing you on the other example, proving that this is not proportional. Because if I take 5.2 divided by 2 and 8 divided by 3.75 and 10 divided by 5, I do not get a constant ratio at all, and I apologize, my repeating bar, this is a small little technicality, is supposed to be here, not here on the 5. My apologies. Maybe your copy, it's already fixed. But bottom line, I do not have a constant ratio. So even though it was a straight line, since it did not go through the origin, it ends up being non-proportional, as you can see from the proof. And what if it's some funky looking zigzag or curve? Is that proportional? Well, definitely not. Even though this does go through 0, 0 here, it doesn't matter. This is not a straight line. This is a curve. And if I take these ratios and divide, they're not even close to being the same. So, bottom line, proportional relationships will always make a straight line, and they will always pass through the origin, known as 0, 0. If it doesn't go through the origin, then it's not proportional. And if it doesn't make a straight line, then it's non-proportional. But there's something else I want to talk about with graphs. We can find the constant of proportionality, which is the fancy phrase that really just means the unit rate. We can find that from a graph if it's proportional. Here's an example. Now, let me read. If a relationship is proportional, it will have a constant proportionality, a constant unit rate. And to find that unit rate, we could take any ordered pair. I actually labeled 2 of them for you here. Actually, this one we can easily find as well. We can take any ordered pair and divide the y coordinate by the x coordinate. Now, I hope you guys remember the order of x and y with an ordered pair. The first number is always the x. The second number is always the y. I labeled that for you here for your convenience. And what I can do is take those y values, the second number, put that up on top, and make the x your denominator. Besides, miles per hour is a logical way of doing it, not the other way around. So 90 divided by 4.5, I get 20 miles per hour. If I took this ordered pair right here, I'll highlight it for you in green, which is 3 and 60. and I divide its y by its x, look, I get 20 miles per hour. So that's one way that you could get the unit rate, also known as the constant of proportionality. But there's a quicker way. Would you like to know the ultimate shortcut for getting a unit rate from any proportional relationships graph? You can simply, I would star this on your notes, ladies and gentlemen, this is good stuff. I would simply just go to the ordered pair where x is equal to 1, because per hour means for 1 hour. So you go to the graph. Feel free to circle this or highlight this on your graph, where x is 1, and go to that dot. Oh, do you see what I see? Right there's the 20, right there. 20 miles per hour. You're like, Mr. Underkoffler, would that trick work for any proportional relationship graph? Why, yes, it would. All you have to do is go to where x is 1, find the y value of that dot, and that y value will be your unit rate. Now, if you forget that shortcut, you could always do it the other way. Not that it really takes super long to divide two numbers in your calculator, but there you go. That's the way of getting the unit rate, also known as the constant of proportionality. All right, let's take what we have learned, turn the page, and let's try two problems on your own. Now, these two problems, if you read the directions, are not asking for unit rates. They're just saying determine whether each relationship is proportional or not. Explain your reasoning. I'll give you a hint. The bottom section of the first page of the guided notes is not where you should be looking. It's the top section that told us what we should have for a relationship to be proportional. So use that to help you here on problems 1 and 2. Hit pause in the video now and do these two problems on your own. All right, how have you already done 1 and 2 on your own? I hope you have. Doesn't really take that long. You're looking to see, do you have a straight line that also passes through the origin? Well, problem number 1 is that type of graph. It's definitely a straight line, and it does go through 0, 0. So this is proportional. And you would simply give me the two reasons why. It is a straight line. Here I just called it a line, because in geometry, lines are straight. But I'm okay with you writing straight line. That's fine. That passes through the origin. Now, what about problem number 2? It is a straight line. Oh, but it doesn't go through the origin. It doesn't go through 0, 0. Oh, I hope you weren't tricked by this one. If you were, fix it. It is non-proportional. And you would go ahead and write down the reason why. It does not go through the origin, even though it was a straight line. Not good enough. Has to be both. All right, problem number 3. New graph now. We got two different sets of data here in one coordinate grid. We got Nick's earnings and Todd's earnings. Mine are in red and blue. Yours are probably just in shades of gray on your copy. But let's take a look at number 3. Which person's graph represents a proportional relationship between the months and the earnings? And by the way, that is a typo. Why have I not fixed this? Mr. Underkoffler, what is your deal? This is not supposed to be months. This is supposed to be hours. So I don't know if you want to fix that typo real quick on your copy. All right, so which one is proportional? Explain your reasoning. Hit pause in the video. Try number 3 on your own real quick. All right, did you already try number 3? If not, please hit pause now and then hit play when you're ready to see how you did. Problem number 3, the graph that is proportional is Nick's graph. Why? Because his is the one that is a straight line passing through the origin. Now you can see they both pass through the origin. But Todd's is not a perfect straight line. It goes like this, and then it goes up much steeper. You can call that a zigzag if you want, but it is definitely not a straight line, perfectly straight line. So that's why only Nick's graph was proportional, not Todd's. All right, problem number 4. In both graphs, let's explain what the point 0, 0 represents. You're like, how do I do this? Well, first of all, don't forget, the first number is always the x, the second number is the y, and the x-axis is the one that goes right and left. The y-axis is the one that goes up and down. If you pay attention to the units of measure, then you'll be able to fill in these blanks that I have already created for in this sentence that I've typed up for you on number 4. At 0 something, Nick or Todd, earned 0 something. Well, the first 0 is the X. That is hours. So that's what you're going to write down. Fill in that blank right now with your pencil. At 0 hours, Nick or Todd earned 0. Go to the Y. The second 0 is the Y. The Y is earnings in dollars. So that's why I already had the word earned there for earnings. Earned $0. So if you pay attention to the labels, especially the units of measure, for the X and for the Y, you'll be able to do a problem like number 4, no matter what numbers I give you for the ordered pairs. This one was 0, 0. Spoiler alert, number 6 gives you different numbers, but it's the same thing as number 4. Pay attention to the units of measure. All right, problem number 5. Speaking of units of measure, I've done most of number 5 for you, but I left the units of measure blank. Let's take a look at this. For Nick's earnings, find and interpret the constant of proportionality. Now remember, constant of proportionality is the same thing as unit rate, and we talked about this on the very first page at the bottom. You can divide y's by x's to get the unit rate, or you can simply go to where x is 1, and that will give you the unit rate, also known as the constant of proportionality. So that's what I did. I either can take the dots here of 2 and 100. Again, we're looking at Nick's graph because his is proportional. And the dot here, which is what, 4 and 200. And take those, write out those ordered pairs, and then divide. Put the y's on top, x's on bottom. And notice, I get 50. That is my constant proportionality. Now, the quick way of doing this is to go to the graph where x is 1. Oh, now this one was a little tricky. X being 1 would be exactly between 0 and 2. And right here you can see, oh, there's my 50. There's my unit rate, my constant of proportionality. Now, let's put the units of measure. 50 what per what? Should I say 50 hours per earnings in dollars? I don't think so. That 50 is a Y. So that's $50 per or for 1 hour. So let's fill in those blanks. $50 sign per hour. I could also say for 1 hour, because obviously that's why I'm going to where x is 1. All right, I think you should be able to do number 6 on your own. I already told you it's very similar to problem number 4. The first number is always the x, the second number is the y, and just like on number 4, pay attention to the units of measure when you write out your sentence. So hit pause on the video, do number 6 on your own, hit play when you're ready to see how you did. All right, did you already do number 6? Let's see how you did. 4 is x, that's 4 hours. Y is 200, the y is in dollars. So I need to somehow say 4 hours, $200, and I need to talk about Nick. So there you go. In 4 hours, Nick earned $200. You could also say Nick earned $200 in 4 hours. I don't care really which way you set up your sentence, but you should be talking about Nick. You better say 4 hours, and you better say $200 or put the dollar symbol. And there you go. All right, let's move on to the next page. Problem 7, 8, 9, and 10. I think you should be able to do these 4 problems completely on your own using what you have learned. So hit pause on the video, 7, 8, 9, and 10 as well. And number 10 has multiple answers, so you're going to be circling more than just one that's true. Try these on your own. Hit pause on the video, 7, 8, 9, 10, and then hit play when you're ready to see how you did. All right, did you already do 7, 8, 9, and also 10? If not, you better hit pause now because I'm about to go over them right here and now. Problem number 7, explain what 0, 0 represents. Well, we got chaperones, we got students, and we're talking about a field trip, so 0 chaperones are needed for 0 students. I could also say on the field trip, because that's what the little heading was saying up here at the top. But bare minimum, you better have the word chaperones with 0 and the word students with the other 0, and there you go. Now, it's easy when they're both the same number, because then you don't have to worry about flip-flopping the labels. But when the numbers are not the same, then you really got to pay attention here. 3 is the x, 30 is the y, the x is the the x is the right and left, the y is the up and down, so x is chaperones, y is students. So we better say 3 chaperones are needed for 30 students on the field trip. Now, do you have to say the word needed? Probably not. But you do need to say 3 chaperones, you do need to say 30 students. And by the way, if you accidentally flip-flopped it, your answer would kind of be hilarious. 3 students will have 30 chaperones? Do you want to go on a field trip with that kind of ratio? I don't think so. So make sure your answers make sense. That's a nice general rule in any kind of mathematics. All right, problem number 9. Find and interpret the constant of proportionality. You know, number 5 was the exact same wording. So I found my constant of proportionality, but then I interpreted it in a sentence. If you didn't do the interpreting part, then quickly hit pause and quickly write it down and then hit play. All right, how do I get the constant of proportionality? Well, there's a variety of ways. You could pick an ordered pair, like this one here, and divide the y by the x. If I take 20 divided by 2, I would get 10. If I take 30 divided by 3, I get 10. But the easiest way of finding your constant of proportionality, your unit rate, is go to where x is 1. And whatever that y value is, boom, that is your constant of proportionality. So it is 10. Let's interpret it. On the field trip, there are 10 students. See, the 10 is a y, so that's students per chaperone. Or you could say for every 1 chaperone or something like that, if you don't want to use the word per. Problem number 10, multiple answers. Let's circle each one that's true. Let me go ahead and get my pen ready. Okay, 80 copies make $2 or cost $2. Wait a minute. The 80 is with the $2. Is the 2 supposed to be? No, the 2 is supposed to be 2 minutes. Whoa, goodbye, A. Part B, the constant of proportionality is 20. Wait a minute. Constant proportionality, where x is 1. That's not 20. That's 40. Goodbye, B. It takes 5 minutes to copy 200 pages. 5 minutes. Yep, 200 pages. Right label, pages. Yes. So C is correct. The unit rate is 80 pages copied per minute. No. Unit rate is where x is 1. It should be 40 pages copied per minute. So goodbye, D. The number of pages copied is proportional to the time in minutes. Okay, pages is the correct label. Minutes, correct label. Is it proportional? Well, it is a straight line. It goes through 0, 0. Oh, yes, indeed. Hello, choice E. And what about choice F? 40 pages can be copied each minute. Each minute is like saying per minute. So we're talking about the unit rate. Oh, yeah. I've said this like 3 times already. The unit rate, where x is 1, yeah, that's 40. 40 pages copied per minute. So I should be circling that one as well. All right, now, not every problem that deals with ordered pairs has to have a graph. Sometimes you're going to have problems given to you completely in words. And number 11 and also number 12, if you flip the page, are problems just like that. Let me go ahead and walk you through number 11, and then you'll try 12 on your own. Number 11, Kyle bought 3 packs of chicken. On the coordinate grid, he plotted each pack's weight, x, in ounces, and the price, y, in dollars. He then drew a straight line that passed through all 3 points and the origin. The line he drew also passed through the point 1, n for some number n. What does n represent? Okay, you're like, that was a lot to read. Well, first and foremost, straight line goes through the origin. This is a proportional relationship. Good to know. What else do we see? The weight, which is x, is in ounces, and the price, which is the y, is in dollars. Now you're like, why is that so important? Because if you start reading these answer choices, they don't always say ounces for the weight and price for the dollars. You got to be very careful here. Now, something else that's worth noting. They're asking, what does the number N represent? And that's from the ordered pair where the X is 1. Now, you're like, well, we're talking about unit rate then. Yes, I agree, we are. But these are not just saying for you to identify the unit rate. They're giving you very specific words. Choice A says the weight in ounces for 1 pack of chicken. Choice B says the weight in ounces for a pack of chicken that cost $1. Choice C that says the price in dollars for 1 pack of chicken, and choice D says the price in dollars for 1 ounce of chicken. If you're getting overwhelmed, let me give you a strategy. Should the weight be in ounces? Yes. But should the other thing be a pack of chicken? No, it should be the price in dollars, not the pack in chicken. So this 1 pack, this 1 is not 1 pack. That 1 is 1 ounce. You see what I did there? I'm paying attention, and you know what? I apologize. I should have made my X in red to stay consistent with what I put over here. My apologies for that. Let me quickly go ahead and fix that. But yeah, the weight should be 1 ounce. All right, weight in ounces. So far, so good. For a pack of chicken that costs $1. Is that 1 supposed to be $1? No, the N is supposed to be the dollars, not the 1. The 1 is the weight in ounces. So goodbye, choice B. The price in dollars for 1 pack of chicken. Is the 1 supposed to be 1 pack? No, it's supposed to be 1 ounce. The price in dollars for 1 ounce of chicken. Finally, we got 1 ounce of chicken, so that's the X of 1. And the N, is it the price in dollars for the N? Well, N is a Y, and the Y is supposed to be price in dollars. Yep. Ding, 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 ding. So do you see what I did here? I paid attention to the fact that the 1, which is X, has to be 1 ounce, and the unknown N has to be the price in dollars. And that's how I was able to eliminate the choices, by paying attention to those details. Okay, I would like for you to finish the last page, which is on the back, of the guided notes on your own. This is number 12, 13, also the multi-part problem 14, 15, and 16, which has a blank coordinate grid. Hit pause on the video, do these 3 problems on your own, and then hit play when you're ready to see how you did. All right, I'm assuming you already hit pause and you already tried the problems 12, 13, 14, 15, and 16. If not, you better hit pause now. Here we go. We have distance in feet for the Y, and we have X is the minutes. They are giving us an ordered pair, so it's good to know this is X, this is Y. I need to find the ordered pair that represents the rate she traveled in feet per minute. Oh, this is just a unit rate problem. You only have to just set up your fraction and divide. Now you're like, Underkoffler, how'd you know the 6,600 was feet? Because I went up here and I saw the distance Y is in feet. Oh, how'd you know the 5 was minutes? Because it says here X, 5 is X, is in minutes. So now I divide. And I get in my calculator 1,320 feet per minute. Boom. There you go. I just solved the problem. All right. Problem number 13. Oh, only one choice is correct. Okay, good to know. Use the graph provided. Okay, circle. Okay. What does the y coordinate represent in the graph when the x coordinate has a value of 1? Okay, so that's going to be my unit rate. X is 1. I'm looking... Oh, what is that dot? Ooh, do I have to guess? Or could there be another way? Ding, 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 ding. You could take the 7 from this dot and divide by the 4. So the work I would write down is 7 divided by 4. What does that give you in your calculator? It gives you 1.75. So goodbye A, goodbye C. It's either B or D. Now how do I know which one's right, B or D? that 1 should be hours. 1 hour. Oh. And the $1.75 should be the dollars. $1.70. There it is. See, choice D tries to say it's $1 and 1.75 hours. It flip-flopped it. So that's why D was no good. You got to pay attention to those details. And finally, problem number 14, 15, and 16. 14 wants you to graph this on the coordinate plane. So go ahead, take each of these ordered pairs and graph those dots. And I would also go a step further. I would label distance in feet. I bet some of you didn't do this. Quickly hit pause in the video and put your labels here for the time in seconds on the X and the distance in feet for the Y's. Problem 15, is this proportional? Well, it is a straight line and it goes through the origin, so yes, it is proportional. And you do have to explain, so hopefully you wrote down a short little sentence saying it's a straight line, goes through the origin. Problem number 16, how fast can the ALK run in feet per second? That's just asking for the unit rate, which is where X is 1. Do I have to guess? Oh wait, I don't have to guess what that is. It's right here. Oh, thank goodness. Easy. Boom. 59 feet per second, and you're done. All right, thanks for watching this video. We'll see you next time.